On this episode of Planet Watch, we will discuss a recently discovered exoplanet orbiting the star TRAPPIST-1. TRAPPIST-1, an ultra-cool red dwarf star roughly 370 trillion kilometers from Earth, was first spotted by Belgian researchers from the University of Liège and was named after a Catholic religious group of cloistered monks famous for the Trappist beer that they brew. This tiny star, being just over a tenth of the radius of the Sun, is one of the coldest known stars in the universe. This allows for planets much closer to the star than in our own solar system to be considered within the habitable zone and be candidates for life and possible colonization. At only 2,511 Kelvin, it is over 3,000 Kelvin cooler than our own Sun. One such planet orbiting the star is TRAPPIST-1e, the fifth of 7 planets discovered in the system. It is the fourth farthest away from the star. However, it completes one revolution around the star in roughly 6 days, making a year on TRAPPIST-1e far shorter than on Earth. Researchers originally discovered the planet using a process called transit, where researchers use changes in the amount of light given off by a star to calculate the rough size and orbital speed of the exoplanet that blocks the light. Scientists use this process to discover multiple of the exoplanets, including TRAPPIST-1e, in the TRAPPIST-1 system 2 years ago in 2017. TRAPPIST-1e is one of 4 planets in the TRAPPIST-1 system that orbit within the habitable zone. This is a zone that corresponds to a certain distance away from the star, allowing for liquid water to exist on the surface of the planet. Though half of the planet is eternally in darkness and the other half is permanently facing the sun as it orbits, there is an area on the border of these two regions where the temperature might just be right for liquid water to exist on the surface. This silver lining is known as the terminator zone and is around 273 degrees Kelvin. It is very possible that more of this planet is, in fact, hospitable, as an atmosphere thick enough to allow heat to transfer to the cold side of the planet might exist. The atmosphere that does exist is low in hydrogen, which is a major greenhouse gas, and would cause the surface of the planet to become too unbearably hot for liquid water to pool. TRAPPIST-1e resembles Earth in many ways. Its planetary mass is roughly 3.796 E24, which is comparable to Earth's mass of 5.972 E24. It has a density of 5.65 grams per cubic centimeter, 102% of Earth's density, and a radius of 92% of Earth's radius, or about 3,600 miles or 5,800 kilometers. Using this information, we can calculate the instantaneous velocity of the planet using the equation velocity is equal to 2 pi r over period t. Using the known radius of 4.38 E9 meters, the radius of the semi-major axis, and the orbital period of 526,953.6 seconds, 6.099 day period converted to seconds, we can find the velocity of the planet at any given time tangent to the elliptical path. The velocity of the planet at any given point would be about 52,225 meters per second, or 52 kilometers per second, a very similar speed to that of Earth, which is about 30 kilometers per second. All of these features make the planet very similar to Earth, and that combined with its location in the habitable zone has slated this planet for future studies and research into the possibility of chemical life on this planet. Another feature that makes TRAPPIST-1e similar to Earth and a planet that can possibly be inhabited is its relatively similar gravity to that of Earth's. Using the equation G is equal to gm over r squared, we can find the force of gravity on the planet. We use the gravitational constant 6.67 e negative 11, the mass of the planet in kilograms 3.796 E24, and the radius of the planet in meters 5.8486 E6. Plugging these numbers in, we can find that the force of gravity on TRAPPIST-1e is 7.40 meters per second squared. Though seemingly hugely different from that of Earth, this is still a feasible gravity to survive in. However, over long periods of time, our bodies would see decreased bone density and reduced strength, as less would be needed under the normal situations of that gravity field. As we continue to discover new technologies and climb to greater heights, it is possible that one day we might find some of our descendants on TRAPPIST-1e and other exoplanets scattered across the universe just like it. Though we are nowhere near being ready to set foot there yet, we continue to gaze out at the stars and discover their secrets. Join us for the next episode of Planet Watch, as we unfold the mysteries of the universe's hidden exoplanets. A special thanks to our corporate sponsors shown on your screen now. And also, we would like to thank viewers like you. Thank you.